Hey everybody, welcome in. Today we're going to be taking a look at Grade 4, Module 3, Lesson 4 problem set from Eureka Math and Engage New York. And in this lesson, what we want to do is we want students to be able to interpret and represent patterns when multiplying by tens, hundreds, and thousands, both in arrays and as well as numerically. So we're going to go ahead and hop in and we're going to really take this example and we're going to model a lot of what we do based on this example. In this example, we can see that the problem is 5 times 10, and they give us this answer of 50. But why is 5 times 10 50? If we take a look over here in this place value chart, we start with the number 5 being shown by these 5 ones. And when we multiply by 10, what happens is those 5 ones shift over to the next place value, which ends up as tens. So we're taking a look at what the value of 5 tens would be. You can even see that they write 5 tens here, and 5 tens is equal to 50. So we're going to take a look at that concept in a couple different examples. Number 1 says draw place value discs and arrows as shown to represent each product. And we're going to be looking at the problem 5 times 100. So let's go ahead and write 5 in our place value chart. And we're going to start with 5 in the ones place. 1, 2, 3, 4, 5 ones. Now, we're multiplying 5 times 100, but I actually like looking down here because this kind of gives us a better sense of what we're going to be doing. Remember, when we multiply by 10, these little figures here, they jump over to the next place value. So when I do 5 times 10, I would end up with 5 in the tens place. And then I'm going to multiply that by 10 again. So these are going to shift over here. And before I do that, I'm going to write the fact that when we move them over, we're multiplying by 10. So again, move them to the next place value by multiplying by 10. And we end up with 5 in the hundreds place. And what is the value of 5 hundreds? 500. So 5 ones, so I had 5 in my ones place, times 100 equals 5, just now in the hundreds place. Number 2 says 5 times 1,000. So I'm going to start this problem exactly the same. I'm going to start with 5 in the ones place. And I'm going to peek down here to figure out how many times I really need to jump place values. So I'm going to do 5 times 10 by taking these 5 ones. Multiplying by 10 means I move them over to the next place value. Every place value is 10 times greater than the one before it. So times 10. Now I need to multiply by 10 again. So these are going to shift to the next place value, which is the hundreds. Again, every time I move one of these place values, multiplying by 10. And I need to do that one more time. So again, they end up over here in the thousands place. So I end up with 5 in the thousands. So 5 times 1,000 is 5,000. 5 times 10 times 10 times 10. Well, 5 times 10 is 50. Times 10 is 500. Times another 10 is 5,000. Multiply by 10 3 times, and I end up with 3 zeros on the back of that initial number of 5. And 5 times 1,000 makes 5, and they end up in the thousands place. So 1,000. Number 3 says fill in the blank with the following equations. So we're going to take the same exact concept. We're just going to remove this place value chart. So 6 times 10, 6 ones times 10. I would have 6 in the ones place. And then I move them to the tens place. So I'm multiplying by 10, which would give me 6 in the tens, which is 60. 4 times 10, 4 in the tens place would be 40. 9 times 1,000, so 10 times 10 times 10 with 9 would make 9,000. Something times 6 is equal to 600. So I need to think, how many times would I multiply, like how many jumps of 10 would I make to turn a 6 into 600? Now I have to do 6 times 10 times 10, and 10 times 10 is 100. 4 times blank is equal to 400. Same sort of thinking here as in letter B, where I need to do 4 times something to arrive at 400. So 4 times 100 would lead me to 400, or I can go back to the very, very beginning ideas of multiplication where I need 4 groups of something to make 400. The size of my groups would need to be 100. Something is equal to 10 times 9, so 9 times 10 is equal to 90. 6,000 is equal to something times 1,000, so how many objects would be in a group if I have 1,000? And that would be 6. 6 times 1,000 is equal to 6,000. Something times 4 is equal to 4,000. That would be 1,000. And 900 is equal to something times 100. So I would multiply 100 by 9 to arrive at 900. On number 4, what we see is that we now have a 2-digit number. So I need to do 12 times 10. And what I'm going to do is I'm going to split 12 into, well, they actually do it for me, into like this unit form. So I have 12 being 1, 10, and 2 ones. I'm going to go ahead and put that in my place value chart. So 12 is 1, 10, and 2 ones. Now we're multiplying by 10. So this is going to get shifted. This 10 is going to get shifted over to the hundreds. And these 2 ones are going to get shifted over to the tens. So now I'm left with 100, 2 tens, and 0 ones to make 120. And 110 times 2 ones is equal to 120. Or I can think of 120 as the fact that there are 12 tens. 18 times 100. So I'm going to go ahead and put 18 in my place value chart, which is 110 and 8 ones. Right, there's 8 ones. And now I'm multiplying by 100. But again, I like to take a look down here because it tells me how many times I need to multiply by 10. So how many jumps I need to make across these place values. So I'm going to start with this 110. And I'm going to multiply by 10. So I jump over to this next place value. And I need to do it one more time. Same idea with these 8 ones. I'm going to multiply them by 10, so they shift over to the tens place. And again, multiply them by 10. Over here it says times 10 times 10. So they need to come over here. Just ran out of room. These should all be in the same box. I forgot to draw that there. So what do I end up with? Well, I have 1 in my thousands, 8 in my hundreds. I have no tens anymore because I shifted them all out of the tens place, and I don't have any ones to make 1,800. So 18 times 10 would be 180. times 10 would make 1,800, which really means I have 18 hundreds. If you remember back from Module 1, remember 1 of a larger place value is equal to 10 of the next smallest place value. So that's why I'm able to say 18 hundreds. 1,000 would be equal to 10 hundreds, plus the 8 hundreds I already have makes 18. Let's take a look at number 6, where it says 25 times 1,000. So let's go ahead and put 25 in the place value chart, which is 2 tens, 5 ones, and we're going to be multiplying by 1,000. So times 10, times 10, times 10. So I need to make 3 jumps. So I'll start with my tens. 1, 2, 3 jumps lands them all the way over here. And every time I do that, remember I'm multiplying by 10. And I'll do that down here with my ones as well. So 1, 2, 3 lands them here. Again, every jump I make is 10 times more than the one before it. So I end up with my 2 in the 10,000s place, and my 5 ends up in the thousands place. So 25 times 1,000 is equal to 25,000. So 2 tens times 5 ones is equal to 2 10,000s. And 5 thousands. Or another way to say this would be 25 thousands. Again, 2 10,000s would be the same as 20 thousands, because one of these is worth 10 of one smaller place value. So 2 10,000s would be equal to 20 thousands, and there's already 5 thousands, which makes 25,000. It says decompose each multiple of 10, 100, or 1,000 before multiplying. So we're going to take these problems, we're going to look at them in a little bit of a different way. So 3 times 40, we're going to decompose this 40 into the fact that 4 times 10 is equal to 40. We're going to multiply this 3 times 4 first, a little bit of associative property here, to make 12, and then 12 times 10. And 12 times 10 is going to be equal to 120. Over here we have 3 times 200, so we're going to decompose 200 into 2 times 100. And now I'm able to multiply 3 times 2 first, which is 6, and this 100 comes down. And I can think of 3 times 200 would be equal to thinking of it as 6 times 100, which is 600. Number 9 says 4 times 4,000. So this 4 is just going to come over. Now 4,000 is going to be broken down into 4 times 1,000. I'm going to do 4 times 4 first, which is 16 times 1,000. And 16 times 1,000 is similar to the types of problems that we were doing up here. But 16 times 1,000 is equal to 16,000. And last but certainly not least, 5 times 4,000 would be 5 times 4,000 would be broken down into 4 times 1,000. 5 times 4 is 20. This times 1,000 comes down, and 20 times 1,000 is equal to 20,000.